Welcome, chemistry students. This is a review of concentration, and then from concentration this week we're going to learn about dilution. But we need to remember what concentration is in order to learn how to perform a dilution. So concentration can be measured in terms of molarity, or can you remember the other way we calculated concentration? Parts per million. Today we're going to talk only about molarity, and we're not going to worry about parts per million. So what was our formula for molarity? You should be thinking of moles of solute over liters of solvent. When you hear the word solute, you might think sugar or solid. And when you hear the word solvent, you might think water or liquid. Now we are going to compare two beakers. So we have beaker A and beaker B. In both beakers we have the same amount of solvent, but we have different amounts of solute. So I've added less solute here and more solute here. Now we can compare these two beakers using a variety of terms. The two I want to focus on are the concentration and on the next slide we will talk about molarity and comparing the molarity of the two solutions. So when we're describing the concentration of beaker A, we want to say that it's less concentrated. Or we could also use the term dilute. Dilute and less concentrated are synonyms. They mean virtually the same thing. Whereas beaker B has more solute in the same amount of solvent, so we would say that this is more concentrated. Now, what we need to be able to do is take a look at beaker A and beaker B and compare their molarity. Molarity is very much like concentration, except we're going to use numbers instead of the terms more or less. So it allows us to quantify the increase or decrease in concentration. So if I were to say that beaker A had a concentration of 1 molar, you would be able to predict that the concentration of beaker B were a number greater than 1 molar. Now let's take a look at two beakers that have the same number of solute particles, but different levels of solvent. Which one is more concentrated? You decide. If you chose beaker D as more concentrated, that would be correct. It's more concentrated because beaker D has less solvent, so the solute particles are closer together. Whereas we can see in beaker E, the solute is more spread out. So we use the word dilute to describe beaker E. Now I want you to compare the concentration of beaker D and beaker E if I add more water to beaker D. So I'm adding water, and I want you to think, is the number of solute particles changing? I didn't see any more solute particles as changing. They have the same number here and here. And now that I've added the same amount of water, these solute particles can move around in the same amount of space as these solute particles. So they are the same concentration. So by adding water, I was able to lower or dilute the solution. So the takeaway here is that adding water will dilute the solution by spreading out the solute particles. A more concentrated solution has closer solute particles, and when I add water, the solute particles have more space to spread out. That's the process that we're going to learn to conduct this week. Good work. Make sure you follow up with the comparing concentrations activity.